Part 1 of Home Energy Basics will focus on energy defined and the key terms that we should be familiar with as we move into an overall program focusing on home energy systems. We'll begin with some key terms about energy and power, sources of energy, and types of energy flows in buildings, and also how important it is to use common language about energy systems so other people can understand what we're talking about. There are two important terms that describe energy that we need to talk about and define a little bit further. A British thermal unit is the energy required to raise 1 pound of water 1 degree Fahrenheit. And this term is important because it's the one we use frequently when we're talking about the size of a furnace or the size of an air conditioner. So the British thermal unit is a term that describes how much heat we need to introduce to a space or remove from a space to keep it a right temperature. So you buy an air conditioner, you see in the label what's actually described in its size about how many BTUs of heat it can remove from a space per hour. A kilowatt is a common term, but an important one that we understand. It's a unit of electricity. It shows up on our electric bills. This is how we buy and sell electricity. And a kilowatt is 1,000 watts, or essentially it's easy to think of it as enough energy to power 10 100-watt light bulbs. Now let's talk about two important terms and the differences. And we're going to try to keep these terms straight and according to the laws of physics. Now let's talk about two common terms and what we really mean by energy and power. Energy is the capacity to do work. So a BTU and a watt are both units of energy. Power, on the other hand, is the rate at which we do work. And this is important because when we size mechanical systems or talk about how much electricity we usually talk about them in terms of a period of time. So how many BTUs per hour do we need in a space to keep it warm? Or how many kilowatt hours do we use over the course of a day and bill a homeowner for? Another pretty important concept for us to understand is where our energy comes from. And there could be an entire course that discusses these things, but there are another important concept to understand is where our energy comes from. And we could spend an entire course on this, but we're going to focus on a couple key terms. But these are all the sources of energy that we use in the United States and the relative percentage of that source of energy in our entire portfolio. So you can see that there are some sources of energy like biomass and hydropower, geothermal systems, wind and solar that we don't use very much of, and our more traditional energy sources of oil, natural gas, coal, and uranium make up the bulk of our energy supply. It's important to understand, however, that these sources of energy are considered to be renewable because technically we can produce them or we benefit from them from the sun, for example, in a sense that they will be non-renewable. These sources of energy all rely on extracting materials from the ground and translating them into energy, and we could technically run out of these. And for that reason we create two terms of renewable energy and non-renewable energy. As the global demand for energy rises, we can expect that our more traditional sources are going to become more expensive and harder to find, and thus a global interest in increasing the portfolio of renewable energy, which for now barely makes up 10% of our overall energy consumption. So let's take a look at a house and talk about some of the natural flows of energy that can be found inside and outside of a home. And we'll start with some common terms that you might remember from physics class and how they affect what's going on in a house. So one way that heat can move through a space is through conduction. And in this particular case, we're talking about, for example, heat inside a house where it's a comfy 70 degrees moving outside the house where it's colder. In most cases, heat will naturally flow from the warm side of a wall to the cold side, and for that reason we try to insulate our homes to try to keep that heat inside. Another form of heat exchange and energy flow is from radiation, and the most common form of that is from the sun. Sun beaming inside a window can heat up a house, and that can be a good thing or a bad thing. In the wintertime, we would love the sun to heat up our house because it will reduce the need to use our furnace. But in the summertime, that warm sun heating up the inside of our house is actually going to make our air conditioners work harder or make us uncomfortable in our homes. Another important concept to understand is convection, and this is the idea of heat rising. So if we introduce heat in a flow register from a furnace, it's going to be introduced to a space, but it'll rise over time and it'll start to cool off. And as it cools, it'll begin to sink down and actually then heat up again, and we'll actually can create a current or a loop of circulating air in a space just by introducing heat on one side. And we actually rely on convection currents to help move air in a space and help keep it an even temperature, as opposed to just being warm at the register. These convection currents can be helpful to keep a space an even temperature. At the same time, because heat rises, our attics tend to accumulate heat, which can be a bad thing in the summertime because they make our house warm. But they also, the heat inside our house will tend to want to escape through our ceilings and up into our attic and outside. And for that reason, creating a warm insulation barrier between your ceiling and your attic space is one of the most important places to insulate a home and the first place to start. So we'll talk about more of those kind of things later, but hopefully this helps you understand some of the different types of energy flows that we need to be aware of as we try to make homes more energy efficient. It's also important to understand that the language we use matters, and we're going to talk about lots of technical terms in this course, but at the same time we want to understand what are the ways that we can express these terms and ideas in ways other people can understand them. For example, we might talk about infiltration and exfiltration, which is air moving inside and out of a house, but to a homeowner we might just use the term drafty, and to help them relate to the fact that yes, they can sense drafts in their home, and that's what we're actually looking for. We might see a term called an atmospheric combustion appliance, when what we're really talking about is a fireplace. Another way to try to simplify language. And air sealing is another one. This will be a very common practice that we try to recommend, but what we're really talking about is using caulk around window gaps and weather stripping around doors to help keep our heat from escaping to the outside. So it's an important challenge for leaders to understand that one of their jobs is to take some complicated concepts and terms and interpret them so that other people can understand them and relate to them and hopefully do something about them.